Right now, right this very moment, I'm connected to a PostgreSQL database. And you're probably thinking, that is so boring. Who wants to see me querying a database, right? Well, wait until you see what I can query from such a database. I can, for example, ask it to retrieve data by selecting cluster, namespace, and name columns from all Kubernetes clusters, and that the data should represent all pods in those clusters. Okay, that might still be boring, since you might be able to accomplish a similar result by creating a simple script that executes kubectl get in a loop. Or it might be boring because you already saw that video over there, which does something similar. But here comes the punch. I can also query resources in my Azure account, like give me a list of all Kubernetes clusters. Now, that is already more interesting. I can query Kubernetes resources and I can query those in Azure, and I can do that using the same interface and the same syntax. Yet, that might not be enough to convince you, so let me tell you that I can also query AWS and Google Cloud and OpenAI and GitHub and Terraform and Slack and almost any other source. It's like having a database that contains information about everything, everywhere, all at once. Isn't that awesome? Isn't it great to have the ability to store information about everything we do, wherever we do it, in a database, and query that data in the same way we would query any other data? That's what Steampipe enables us to do. It allows us to pull data from almost any source into a PostgreSQL database and query it. On top of that, there is almost no learning curve. If you have at least basic knowledge of SQL, you can use Steampipe. If you don't, then you have a serious problem that cannot be addressed by this video. Now, if you're still here, it means that basic SQL does not scare you, hence I can give you TLDR right away. Steampipe has its quirks and rough edges, yet if you manage resources in multiple locations, as almost everyone does, it is amazing. It might easily become one of your best friends, which might or might not turn up to be later on. So, what is Steampipe? A short description is that it is a tool that queries APIs, stores the data behind those APIs into a database, and allows us to query that data. Those APIs can be almost anything. It supports over 140 of them through plugins, so I can safely say that if you work with something that is not supported, you're working with antiquities and should consider replacing that something. Unless you consider yourself a collector of long time gone systems. The data is stored in a PostgreSQL or SQLite database, meaning that we can query the data just as we would query any other data. We can join data from different sources, we can filter them, or we can crunch them in any other way. Okay, so that's enough of a pet talk. Let's dive into it. Let's see Steampipe in action. I already set up a few Kubernetes clusters in Azure, and each of those clusters has some random resources running in it. Think of it as a mini simulation of what I might have in production. Besides that, I did not do anything else except install Steampipe CLI. There was no special setup done in advance, at least not when Steampipe is concerned. To begin with, we might want to take a look at the currently available plugins. We can see that AWS, Google Cloud, Azure, OpenAI, GitHub, Terraform, Slack, and Kubernetes are there. And that's only a fraction of 143 plugins. The only thing we need to do is install one of those plugins. So let's start with Kubernetes. Installation of that plugin created a Kubernetes SPC, spec probably, config file. So let's take a look at what we got. If we ignore the comments in that file, it all boils down to 2 lines. It is the configuration for the Kubernetes plugin that instructs Steampipe to pull not only Kubernetes resources that are baked into the cluster, but also all custom resources. Since we did not specify otherwise, whichever Kubernetes cluster our kubeconfig is pointing to will be synchronized into a PostgreSQL database, eventually at least. However, that's not what we might want. What would be the point of having the ability to query data based on resources in a single cluster? There would be no need for Steampipe or something like that. We could do that with kubectl. So let's change the config to use 3 clusters. The new configuration specifies kubeconfig path, the context, and just as in the default config, all custom resources for each of the clusters. As an added bonus, the last entry creates Kubernetes all entry, which, as the name suggests, will aggregate data from all 3 clusters. We are accomplishing that by saying that entry is one of the aggregator types and that it references all connections with names starting with Kubernetes _, which in this example are literally all connections. Let me give you a big warning though. We can specify any number of custom resources in the custom resource tables array, but if they differ, Steampipe will get confused. You see, even though Steampipe is awesome, it's not very bright. It gets easily confused. Hence, keep all entries the same. If you try to specify something like sync those resources from that cluster, but some other resources from some other cluster, Steampipe will go bazooka. It will get so confused that it will start producing unexpected and sometimes even misleading results. Anyway, now that we configured Steampipe to work with 3 Kubernetes clusters, we can use the CLI to query it. And from here on, we can, for example, ask it to inspect itself. We can see that it established connections with the 3 clusters as well as the aggregate connection to all the clusters. If you would like to see which tables it created for, let's say, the AKSO1 cluster, we can inspect that as well. We can see the tables representing resources and custom resources are there, all prefixed with Kubernetes to distinguish them from tables coming from other sources. For example, if you're interested in deployments, the data is stored in the Kubernetes deployment table. Similarly, we can output all the tables no matter from which source they were created. Since for now, the only source are Kubernetes clusters, we can see tables coming from all clusters, from AKSO3, and so on and so forth. Once we discover what is available, we can start querying the database and, for example, retrieve all deployments. We can see that silly demo from the A-team namespace is there, that crossplane from crossplane system is there as well, and so on and so forth. Since more often than not, we cannot fit all the columns and rows on the screen, we can scroll left and right and up and down and observe whichever data we are interested in. Once we are done, we just need to type Q to exit the view. There are many other quality of life features, like, for example, autocomplete. We can just start typing something like select all columns from Kuber and select what we are looking for by pressing tab to choose the next match, or shift tab to select the previous. Or we can continue typing until the number of entries is limited to close to what we need, select what we're looking for, and press the enter key. Now that you saw me retrieving all the columns, I should say that you should probably never do that. If you ever worked with SQL databases, you know that asterisk can cause significant performance issues. To be clear, that's not necessarily the issue of Steampipe, but rather the issue with PostgreSQL or any other similar database. The more data we have, the more dangerous it is to retrieve all the data from a table using asterisk. Instead, we should find out which fields we're interested in and specify them explicitly. We can do that by taking a look at the table with the inspect command. And there we go. That's the list of all the fields that represent Kubernetes pods. And we can easily observe 2 potential issues there. One potential issue is that values of fields deeper than 2 levels are stored as JSONB. For example, the spec containers field in a pod is stored as containers field of type JSONB. Whatever is inside containers, and there's a lot, is all stored as a big blob. In some cases that's only an annoyance, while in others it prevents us to do what needs to be done. Let me explain that through a few examples. For example, if you would like to output the connection name which represents a cluster, we will quickly find out that there is no such field. Instead, it is stored in the CTX field together with some other information. So we would need to select the CTX together with whichever other fields we need. As we can see, the name of the cluster is stored as JSONB field connection name inside CTX. Fortunately, we can select specific fields from JSONB and output their values as columns using -- and then greater than. So we can say something like select CTX column, extract connection name, and output it as a column cluster. That output makes so much more sense. The additional instructions we had to perform or type represent annoyance with values stored as JSONB. We can extract data we need, but the syntax becomes more complicated. It's not the end of the world, it's just a tiny annoyance for now. So let's go to the bright side. Let's turn to less depressing parts of Steampipe, like for example the fact that we can use where statements to filter the results. We can, for example, specify the cluster name, ready replicas and replicas fields from Kubernetes deployment table and add the where statement that will limit the output to data from pods residing in the namespace A-team and the name set to silly demo. And look at that, that's awesome and potentially easier than if you try to accomplish the same with kubectl looping against all the clusters and using namespace field and label selectors and what's not. We can even do fuzzy search with the like statement that will return all deployments with the name that contains the word something. The output contains almost the same data we get with kubectl get deployments, but with data from multiple clusters. I can safely say that any type of queries beyond the simplest ones become much easier to do with SQL than kubectl combined with a lot of shell scripting like loops, greps, regexes, and so on and so forth. We can also combine queries with the union. For example, let's say that we are interested only in deployments from clusters O1 and O2. We could get those by selecting deployments from one cluster and combining them using union with the data from the other cluster. We can also order results by using the order by SQL instruction. And there we go. The results are now ordered by the context which contains the cluster and by the namespace. As you saw from the configuration, we are not limited only to resources baked into Kubernetes, but we can also query custom resources. For example, we can select data from Kubernetes SQL table that contains SQL resources based on custom resource definitions. Now, let's get back to the depressing part of Steampipe, mostly caused by the usage of JSONB data types. We can extract data from JSONB in select statements, so we can say that we want size from the parameters field as well as version from the same field. We already saw that in action. What we did not try is to use data extracted from JSONB in from or where statements. In this example, I would like to join data from tables Kubernetes SQL claim and Kubernetes SQL. To do that, we need to specify which fields contain matching data, which in this case would mean that SQL claim name contains the data that match SQL labels field crossplane IO claim name. You can probably guess what will happen, but let's see it just in case you guessed wrong. You didn't, but just in case. There we go. Nope, it's not happening. We cannot combine text and JSONB, at least not in from and where statements. Unfortunately, parent-child relationships in Kubernetes are always based on labels, thus making it close to impossible to get such data from Steampipe. Similarly, we could not, for example, retrieve all resources that fail to start since conditions are also JSONB field, not to mention events that are not even stored in the database. Now, to be clear, we could probably, most likely, perform some dark magic rituals to make it work, but I don't think it's worth it. Using JSONB to store complex data instead of extracting them to separate columns might have seemed like a good idea that simplifies the work on Steampipe, but ultimately it is a huge mistake. And another mistake is performance. I can demonstrate that by starting over from scratch. So let me exit Steampipe and execute an ad hoc query. You will notice that it took a couple of seconds to retrieve the information. Steampipe does not proactively pull information. It's not getting data proactively. Instead, it does the pulling on demand. Now, you might say that's okay, since it took only a couple of seconds, and you would be right. But only when small setups like the one in this demo are used. On bigger systems, it can easily take minutes or even more to load fresh data or see cache data that is out of date. Clusterpedia solves that problem by proactively storing all events into the database. That is a separate process unrelated with querying data. Now, the price to pay for that is that Clusterpedia needs agents running while Steampipe doesn't. Hence, you need to figure out whether you prefer up-to-date, lightning-fast retrieval of data through Clusterpedia or agentless model of Steampipe that is slower and can return outdated information. Also, please take a look at that output from ad hoc queries. It's useless. And I honestly don't know what to do with it. We can output it to other formats like, for example, JSON, but that's not very useful either. However, I can blame myself for that one. I should have limited the number of selected fields. Also, you will likely do the queries from the Steampipe shell and use those ad hoc queries in automation like CI pipelines, assuming that you need Steampipe there anyways. Now, here comes the best part that distinguishes Steampipe from, let's say, Clusterpedia. We can query data coming from almost any source. So let's add, for example, Azure to the mix. And now we can go back to the Steampipe shell and inspect Azure resources. From here on, the process is the same. The scope increased, so now we can, for example, ask it to list all Azure resource groups. And that's it. That is Steampipe in a nutshell. Now, let's talk about pros and cons. Steampipe reminds me of Clusterpedia. The major difference is that Steampipe is generic while Clusterpedia is focused on data coming exclusively from Kubernetes clusters. Both approaches have their pros and cons. Both are using PostgreSQL to store and query data. The major difference is how we query that data. When using Clusterpedia, we might not even be aware that there is a database behind it since it exposes everything through a Kubernetes-compatible API. Hence, we can use kubectl to query data as if all clusters are a single cluster with resources having additional labels added to it. Clusterpedia can do that since it has a limited scope. It works only with Kubernetes resources. Steampipe, on the other hand, is a completely different beast. Its scope is essentially everything. AWS, Azure, Google Cloud, Kubernetes, Slack, OpenAI, and almost anything else one can imagine can be a source of data. The price for such a wide scope is that we cannot work with data from any of those sources natively. We cannot query AWS resources using AWS CLI, nor Kubernetes resources using kubectl. It's all SQL and only SQL. Now, that is not a bad thing. SQL is simply yet much more effective way to query data than querying APIs directly or through CLIs. As a matter of fact, I still don't understand why we still keep etcd in Kubernetes. It should be replaced by PostgreSQL or any other SQL database. Still, no matter how great SQL is, Steampipe has a few issues. So let's start with those. To begin with, Steampipe does not keep history of resources. We cannot go back in time to look at changes, explore issues, or whatever we might want to do with historical data. I feel that is lost opportunity, since PostgreSQL is certainly capable of having a large number of records. Next, it is irritating that there are no default views. If we execute kubectl get or AWS list or gcloud list commands, we always get a selected number of columns in the output. With Steampipe, if you execute select without specifying the columns, we get all. That's a pity, since more often than not, I tend to list resources based on certain criteria and then dig deeper. The Kubernetes plugin could have gotten the list of columns that should be displayed by default from CRDs and could have created some views or used some other mechanism to create defaults. Now, to be clear, it's not a big deal to specify all the columns we need, but it would be nice to have default views. Next, querying data sources can be slow, since Steampipe needs to contact each API to demand something and wait for the response. It does use caching to somehow mitigate that, but the cache is often obsolete. It would be better, but more obtrusive, to have some kind of agents that feed the database whenever destination resources change, thus keeping it always up to date and lightning fast to query. Anyway, performance can be an issue. And now comes the part that annoys me the most. It uses JSONB fields to store data as blobs. That creates complications when specifying fields we want, and at the same time, it makes it very difficult, if not impossible, to use data from blobs in from and where statements. Hence, we cannot run queries that would, for example, retrieve all unhealthy pods, at least not without performing witchcraft rituals. What else? Filtering data that should be imported, like custom resources in Kubernetes, cannot differ from one cluster to another. Actually, we can specify resources that differ from one cluster to another, but in those cases, Steampipe goes crazy. So even though in theory import rules are flexible, in practice they are not. Now, to be clear, not everything is bad though. As a matter of fact, Steampipe is a great tool, and many of those downsides come from the fact that its scope is unlimited. It can work with anything, and the price to pay for that are quirks like those we just discussed. And that leads me to the biggest advantage of Steampipe. It works with almost anything. We can instruct it to fetch data from almost any cloud service known to man, and that's huge, massive. That's amazing and probably outweighs the downsides often caused by such a wide scope. The next big one is SQL. Everyone knows SQL, so there is almost nothing to learn. It's powerful, yet simple. I cannot imagine any better option for such a scope. Given that we might deal with many tables and columns, the addition of the autocomplete feature is like cherry on top of a cake. It simplifies greatly the process of writing SQL queries. So here it goes. Here's the final verdict. If you need a single pane of glass only for Kubernetes clusters, Cluster PD is a better choice. However, if you need to extend the scope to other data sources, Steampipe is the right choice. Personally, I believe that we should use Kubernetes to manage resources no matter where they are. So in my case, all the data is available in Kubernetes clusters. That's why I embraced crossplane. Kubernetes should be the control plane for everything. With that in mind, for me, Clusterpedia is a better choice. However, I'm fully aware that not everyone shares the opinion that Kubernetes should be the control plane that manages everything. For those, Steampipe is the right choice. Thank you for watching. See you in the next one. Cheers.